Hello, in this video you will learn how to create a transaction, specifically a transfer transaction for ETH using C#, .NET 9 in this case. This should be valid anywhere from basically .NET 5 or so. It should also work in .NET Framework. And this will be using Nethereum library, NuGet package, which is basically what you should use essentially in any sort of Ethereum ETH arrangement in C#. We're also using Ganache for testing. Very useful, great thing. Unfortunately, it's sort of being retired. It's not being supported anymore. It still works if you're just getting into ETH, Ethereum development. Very good tool to use because it does have GUI, and basically all you need to do is download it and then run it, and you just copy the RPC server, so your local host essentially on which it's running, and then you get all these addresses provided. You get private keys. Just click on the key icon there and mnemonic words, everything is there, so very easy to get started. Now, in terms of the actual transaction, let's get to Visual Studio. And as you can see right here, we are using Ethereum Web3 and Ethereum Web3 accounts in the using statements, but to elaborate on that a bit, in the NuGet packages, we have Nethereum.web3. This is what you need to use. Now, all of this whole example will be available on Patreon. Do check it out. There's free courses on there. If you purchase one of the memberships, there's lots of good things. The source code is there for sure, but many additional things as well. Now, in this case, we just have a bit of a setup going on first. We have private key and recipient address, and the purpose of this is not just to show you how a transaction is made, it's also how to verify it. So not just sort of wait for it to complete, but also verify that hash that is returned essentially to see that it is has been done, to associate it with something, so sort of asynchronous verification. So we'll get to that at a later part of the video, but for now, just to get started, we have some bits and pieces of data. Private key, recipient address, you will see where it's used later, but first is the Ether amount. Now the amount, as you may already know, we do transfer Ether, but in some circumstances, in some cases, in some libraries, and in some various arrangements really, you might see all of these various other amounts. So it's essentially like, you might say like cents on a dollar, so, well, cents on ETH in some ways. There's Gwei, and all these other amounts. And again, you can download the source code on Patreon. You'll find this probably quite useful in some cases. So the most useful ones are certainly Wei and Gwei. Those are the most commonly used. The other ones do exist to some extent, but certainly not in these libraries. So mostly we just go with these two, and obviously with the actual ETH amount. Now, the next thing is to initialize the account from which we send the amount. So we are handling the sending, we're sending the amount. Of course, you may use a library, that's a whole different thing. You might be using Blazor and getting private keys from there and setting up the account like that. Well, that's a whole different thing. This is more when you actually have the application, but it still applies. The sending process will still apply, it's just the way you construct the actual account. In this case, we have a private key from Ganache. It's all in local environment, so we can create the account from the private key, and we have the account right here. Also, the account will take the URL, so whatever node you're using, that will be the URL, basically. The next thing is checking the balances. Now, you don't have to do this. You certainly don't have to do this at all, but it might be useful if you want to just sort of check if a balance has a certain amount. If your balance has a certain amount to pay out, maybe you want to withhold the payouts until it has that certain amount. It doesn't necessarily have to be a certain amount for that particular transaction. If you're sending perhaps lots of different transactions to different people or things like that, you might want to check for that. This is not a mandatory step, but this is including just to kind of show you how to do that. So basically you access those RPC endpoints, ETH, get balance, and then send request to the get balance endpoint, and you get from the address the actual balance. The interesting thing, however, here is that we get the balance in Way, not in ETH, but in Way. And so we probably, in case we want to visualize this, or in case you have it somewhere in your database or something like that, you want to convert it to the right structure, essentially. So for that, you don't have to necessarily divide or multiply by one of these numbers, but there are some conversions included for most of these. So essentially from Way, it will be included in Web3, convert from Way. Very useful thing. If you need to do this conversion, I would certainly suggest doing it this way, because there's less room for error. It's already been tested. It's already been used by thousands of people developing using these libraries. So it is verified, and there's, again, less room for mistakes. But moving on, creating the actual transfer, essentially. For this to happen, we need to get this transfer service. Essentially, kind of like constructing your thing, but we're not constructing, we're getting a service. So nothing really too fancy here. We get some details for the actual transaction for this, but essentially all of that can be sort of ignored, or all the what happens here. You won't need to modify this, most likely. There are some more advanced cases, but most often you'll deal with something like this. If you need to deal with more advanced cases, that is a completely different thing. But we do this from, again, Web3, which takes account and URL. We constructed that already. And then we get the transfer service, and then the transfer service has all the things it needs to have to create the actual transfer, to both create and transfer. This is quite convenient. Unlike Solana libraries in C#, for example, you can go watch some videos on the channel, or you can go watch the course linked below on how to get started with the whole Solana thing, also calling on the programs, implementing the Solana programs, which are like smart contracts in Ethereum. You can watch that course. Very useful course, quick course, and you'll learn a lot about Solana. In C# as well. That would be a bit more complicated in terms of structuring a transfer. However, this is relatively straightforward. We just transfer Ether and wait for receipt, just like the method suggests. All it takes is the recipient address. So this is the public key, essentially, right? Not the private key. We just need the public address is what we need. Something that may seem quite obvious, but it does happen that sometimes people confuse it. But this is to address, so that is the recipient. If you have your wallet, you send it to someone, you send to the recipient address. And then the Ether amount will be in Ether. That is something, again, quite important to note, because, for example, right here, when we get the balance using send request to sync from get balance, we need to convert it from Way, because we get in Way. But here we send the amount in Ether, just like we have it stated right here. Ether amount 0.01. That's the amount. So after that, the receipt will have something quite useful. We do have a block number, which we can use for some things, so we won't get into that right now. But more importantly, we have the transaction hash. So we have some kind of a reference on the chain for that particular transaction, right? So the transaction already happened. Probably it succeeded. Probably, maybe, who knows, right? We need to verify. More importantly, if this is done somewhere on the front end, right, you will need some kind of a way to verify the transaction on the back end, right? You cannot trust some kind of an API call to your backend from a front end from which a transaction happened. Someone will hack your system. It will be very, very easy to do that. There will be no interaction with a blockchain, so you don't know if that transaction hash happened or didn't happen, even if you send it somewhere along the line, right, and store it in a database. You need to verify it. You need to verify the amount that was sent, first and foremost, and then also that it actually, well, worked out at all. So for that step, you would use something like this. And again, this is for the example purpose. This isn't one thing, but you would probably have one of the parts somewhere, most likely. If you're doing this for some user, it will be in the front end, and this would be in the back end. Of course, many different arrangements are valid here. But even if you don't do it like that, you would probably want to verify it separately, asynchronously, if you will, just in case something fails while inserting the transaction in the database, even if you send it or something like that happens. You always want to verify payments asynchronously so you can repeat the verification without having to repeat the actual transaction. That is the best practice in these cases. So we do have all this. For now, let's just skip a bit ahead without the verify payment. I will talk about that later, but we can also check the balance after the sending, so the balance will be lower. Now, I did already send one of the transactions, so as you can see, the balance has changed in Ganache. The Ganache still works quite well. Who knows how long it will still work without the support, but it should be quite good for some time, because the other tools available, and there are plenty, they do not have GUI, so it can be quite tricky to use for a beginner if you just need to do something very quickly and it's not perhaps the main feature of your whole life, this whole arrangement. So it is quite useful because you only need to download Ganache and it works. Now, let's get to the verification of a payment. Quite an interesting arrangement here. In this case, we do take the same Web3 with the same account. You don't necessarily need to do that, but it's what we do here for simplicity's purposes. But you wouldn't need to do the same account essentially to get the transaction hash, because this one we don't send transaction, we don't pay anything, we don't do anything like that. What we do is we access the RPC to get the transactions and to get transaction receipt based on the transaction hash provided. That is the main thing. Now, at this point, we would already have a transaction. So what I will do now, let's run the application. Let's see what the receipt, the actual bits and pieces of a receipt looks like. Running it on local network is basically instantaneous. So obviously it won't be like that on the main nets, and you shouldn't expect that, but generally it is very useful to test on these local ones just to find it all better. But the transaction hash, of course, is just a hash, nothing interesting there. But the receipt is what we are interested in, and it does have quite a bit of data. We have the block hash, and the more interesting things would be something like effective gas price, gas used, so you can track that. You can see what the fee was for the transaction. Obviously, that's very important if you're tracking that. If you're perhaps implementing this alongside other payment options or transfer options, payout options, you want to always track those fees. In all the blockchain world, fees, as you may already know, is make or break for many arrangements. So it is important to track them, and it's something you might want to log if you're doing that. But we also have from, and we also have all the hashes and the type of a transaction. Basically, quite a few things we have here. But let's move a bit forward, just to check a few specific values. We want to check the status, and the status is 1. In this case, value 1. If not 1, then we know it's an error, so we throw an error, right? Basically, at this point, you probably wouldn't save that to your records, or you would save it as failed. Possibly you would do that, and then perhaps notify the user or something like that. But it has to be 1 in order to be successful, so if it's not successful, then it failed. Now, this one was successful, so we can move along. And retrieve the actual transaction, right? This is very interesting. So we received a receipt. We use transaction hash to receive a receipt. We cannot directly get a transaction from the transaction hash, which can be a bit annoying, but that is usually how all the blockchain arrangements go. If you watch the Solana course, you'll see it's kind of very similar to this arrangements as sort of leaps and bounds to go through in order to actually get to the data that you actually need. But it is possible, and that's how we have to do that. So in the transaction, let's take a look at the transaction, you get a lot more data for the actual transaction. I guess you get all the fees and all those things. Generally, the suggestion will be obviously to get the transaction to get the fees, but you already saw the fees previously, so if you only need the fees, you only need the fees, and that will be there. However, what we are looking for here is the actual value, and the value will be, let's move a bit further on, the value will be in the value and in the value of the value. A bit weird, but that's kind of how it is, because value is a number, which is a nullable number, and we can check for whether it has a value or not, or doesn't have a value. A very simple arrangement, really. Just remember to make sure that that's how you get it. And then we convert it from way. So it is a bit weird again, a bit counterintuitive perhaps. We send a transaction in ETH without any sort of cents and decimals and parts and bits and pieces of thing. But then we receive all the data in way. Well, that's just how it is. That's what we have to deal with. And we do have this wonderful converter to use it to get it from way to ETH. And then we can do this relatively fancy is valid arrangement. We check if the sender is expected sender, so from whom the transaction was received, right? So if you have an account associated, or if your account really is that account, right? That address rather, well, then that's what you check for. So, okay, that's from whom it was received. And then you check receiver. Well, you probably don't necessarily have to check that, but you certainly do have to check for the amount. That's quite important, because you can verify the transaction. Okay, it worked, it's good, but if you didn't have full control of creating it, probably it's best to check the amount as well, so you know that the amount agreed was transferred and all that. There are more things you can do with this. There are additional messages. Obviously, if you have very complicated transactions, perhaps going into the world of smart contracts would be even more valid. But that is not the topic for this video. You can download all this source code from Patreon, also find some free courses on there. Based on memberships. Most memberships include all the courses, and certainly source code is available, and there is more to come. And do check out the Solana course as well. Quite a useful niche skill in some ways to learn. Using C# works very well. The libraries are now up to date. Great thing to check out. And with that said, we will conclude this video.